Okay, so now I'm preparing just in case. Tomorrow I was hoping to be able to teach this one in person, especially because it was going to be the last time that I saw you guys before the test. Now I am having a little bit of pains. Could be nothing, could go away by the morning, but just in case, I'm going ahead and recording this. Just my luck, Microsoft Stream, which is the thing that we use to be able to record the classes that we have in class, is down. So like I recorded all the classes from Tuesday and they're still processing. So those videos are not available. So I've decided to record this one, save it on my computer, and then I'm putting it on my YouTube channel because YouTube should not be down, hopefully. And since you're not at school anyways, and even if you were at school, YouTube should not be blocked. So it is something that you will be able to access. So today we're going to cover quadrilaterals in the coordinate plane. I'm just going to work through all of them with you. Just go ahead and work all of them out so it's not a homework assignment, it's something that you can study for the test. I'm also going to do these notes with you. They're 2 sheets. And then this is your homework. It doesn't say homework on it, but it's more practice. So I want you to try to do that on your own. Now, as long as the video has not been too long, I might do a few with you just to show you how to do them. You definitely want a calculator. Excuse me. For these, because it's a lot of formulas. And since it's a lot of formulas, it's a lot of plugging in. Using one on the computer or using one on your phone would be helpful. Okay, so we're going to start with this one. Again, I'm going to walk you through this whole page, have it done so you can use it on the test on Monday. Now, if I were to go into labor, I still haven't put the test in to Microsoft Forms, but I think I could get it done by Monday, because by that time it would be like 4 or 5 days. So you should definitely have a test on Monday. No worries if I go into labor or not. Hi, baby. I don't think it'll be an issue. It should be something I can do quickly, even if it's just 10 questions, you know. Okay, so I'm going to go through the steps. Now I'm going to tell you what you need to do, and then we're going to do the work. So first, I'm going to write out a sentence as to what we need to do. So on parallelogram PQRS below, if P is located at -1, 6, so I'm writing that in. Teo, bájale, papito. Ven. So I'm writing in what they gave me. S is located at -7, -3. So I'm going to write that one in. So S is over here, and it's -7, -3.
What?
Okay, so we have those 2 points given, and then it says, what is the slope of QR? So I'm going to tell you exactly what you need to do. So we're going to have to find the slope of QR. Now, because this is a parallelogram, if I can find the slope of the one across from it, it's the same. Because parallelograms have the same slope across. So all you have to do is find the slope of SP. Okay, now I would pause it here, go back to your notes if you have forgotten. It was the first set of notes that we did when we talked about slope. See if you can remember how to find the slope of SP. It was the first set of notes, but it was the one where we did like 3 questions on the homework. Now, if you don't remember, I'm going to walk you through it now. You're going to take and use this formula here. So in the future, if we have to do slope on any of these, once I've already written down the formula, I don't have to write it down again. I guess I should keep it consistent, so this should be x1 minus x2. Okay, So if you were stuck and now that you see me write the formula, maybe it's coming back to you, again, pause it, see if you can figure out what you need to do from here. Okay, I'm going to keep going. So first, I'm going to grab my y1. You can choose whichever one you want to be your y1. So I'm going to pick 6 minus negative 3. That's going to be my y2. Then my x1 has to be negative 1 minus negative 7. Okay, that becomes, a double negative becomes a positive. So 6 minus negative 3 is 9. And then negative 7 minus negative 1 minus negative 7 turns into a double negative. So a double negative is actually going to be a plus here. So negative 1 plus 7 is the same thing as saying 7 minus 1. So it's going to be 6. Now our last step is to reduce this. We can divide the top and bottom by 3. So my final answer is going to be 3 over 2. Now remember, since these two are parallel, the slopes are the same. So I know that the slope of QR is equal to this right here. Okay, so that's it on that one. Okay, the next one, on rectangle. So this is a rectangle, and the key words are the shapes that they're giving us. So this is kind of summing up everything that we've kind of talked about over the shapes. Okay, so a rectangle ABCD below, if A is located at 3, 4, and B is located at 7, 6, what is the slope of BC? Okay, so based off of the numbers they gave us, we're going to be able to find this slope here. Now this is a review from Algebra 1, and we haven't really talked about it. We didn't have to do it in the rectangle homework or anything like that. But when you're given the slope in a rectangle of one of the sides, you're not going to have this side be the same because they're not parallel. They are perpendicular. That means we can put like a little box here, okay, which is something we already know. But what is true about their slopes? So I'm going to write it here so we know. These are our steps. You're going to find the slope of AB, because we have those 2 points given, so that's why we have to find that slope. And then, step number 2, flip and change sign. Okay, and I write it this way because it'll either go to negative or positive. And I should put a D here. Okay, so you're going to flip the fraction and you're going to change the sign. So pause it here if you think you could find the slope of the yellow one and see if you could flip and change the sign on your own. We'll keep going in just a second. Okay, I'm going to keep going. So now, first I need to find the slope of AB, which we already figured out the formula, so I don't have to write it down again. Okay, the slope is going to be, so again, grab one of them, so 4 minus 6 over 3 minus 7. 4 minus 6 is negative 2, 3 minus 7 is negative 4. Now, the negatives cancel out, and I do reduce this by dividing the top and bottom by 2, and I get 1/2. Okay? Now, this is not my answer of the whole thing. We need to, in order to find the slope of BC, we have to flip and change the sign. Okay, so the slope of BC is, let's flip this, so 2 over 1. And let's change the sign. This number here is positive, so this one will be negative. Okay, so it's something new. So that's why, again, I decided to go through and just help you guys out and have all of this so you know all of the answers. Okay, let's keep going. Again, if you need to pause it, go back, to get some of those answers, you can. Okay, we're going to move on to 3. The keyword in this one is rhombus. Okay, on a rhombus, W, X, Y, Z. If W is located right here, put in the number -5, -2, and Y is located at 3, -2, what is the slope of XZ? Okay, we're basically going to do the same kind of steps that we just did on number 2, because in a rhombus, if you remember, diagonals are perpendicular, which is that box. It's the same box we drew in the corner over there. So if we can find this slope, because those are the parts that are given, right? Those are the points. Then if we flip and change the sign, we will get the slope that's perpendicular, which is the one that we need. So once again, I'm going to write the steps. So you're going to find the slope of WY. Then you're going to flip and change sign. Okay? Again, if you need to, pause it here so you can go through and try to get the answer. Okay, so I'm going to keep going, do the answer to this one. So we're going to find the slope of WY. So slope of WY equals, take my numbers. So again, I'm going to do -2 minus -2 over -5 minus 3. Okay, so this turns into a double negative turns into a positive. So -2 plus 2 is 0 over -5 minus 3 is -8. Okay, now anytime you have 0 at the top, your slope is just going to be 0. It's going to cancel out the -8 on the bottom, so it's just 0. Now this one is a trick for flipping and changing the sign and all that, because the slope of XZ will be the following. If this is 0 over -8, then this is going to be -8 over 0. You can never have 0 on the bottom of a fraction. So as soon as you see that, you should write the word undefined. We can shorthand it with just UND. So that's something that you should have learned in Algebra 1. Maybe revisited it in Algebra 2, but undefined slopes and 0 go together. So if you ever have a 0 slope, the opposite would be undefined. That's the perpendicular one. Basically, this is a horizontal line, and this is a vertical line. That's all that is. So now that we have that, we'll move on to 4. And again, I'm giving you these because I do think they're a little bit difficult, and I want to make sure that you have these completed, so I didn't want to leave this as a homework assignment. Okay, we're going to move on to number 4. The key word in that one is square. So remember, square is the perfect shape. It encloses every property that we've had, so keep that in mind. Okay, we're going to write in the values. J, K, L, M is the square. If J is located at -2, 5, and K is located at 2, 2, what is the slope of LK? Okay, so LK is this one. That's the one they want us to find. Here is the 2 points that were given, this side. Now remember, just like a rectangle, they meet up at 90 degrees. So what we're going to do is we're going to find the slope of JK, and then you're going to flip and change the sign. Once you do that, you'll have the answer. So again, if you want to pause it here, see if you can find the slope of JK using the points that they gave you there.
Mama, is it zero? No.
Okay, so I'm going to keep going here. So we have JK. The numbers for JK would be these two. So I would do 5 minus 2 over negative 2 minus 2. 5 minus 2 is 3. Negative 2 minus 2 is negative 4. Okay, so this is your answer. I do like to pull the negative out to the front. I don't like it to be on the 4. So there's my answer for that one. Remember, this is not your final answer because you still have to flip and change the sign. So I'm going to flip this and change the sign. So the slope of LK will be 4 over 3, because I flipped it, and change the sign. If this one's negative, then this one's going to be positive. So there's my answer. Okay, we're going to keep going to number 5. Okay, so number 5 is on a parallelogram. So this is just the basic shape parallelogram, which is actually the first one we learned. Had a lot of properties, but didn't have things like right angles. The diagonals weren't congruent, you know, things like that. So it had some properties, but not all. So just keep that in mind. Okay, on a parallelogram STUV, if S is located at negative 4, 1, and T is located at 5, 3, what is the length of VU? The key word is length. We haven't had that. We've been using slope on all of these. Okay, when it says length, you're going to do distance formula. But remember, I don't like distance formula. It's just something that I feel like students mess up on. So I like to use the trick of the number line. Now, one of the properties of a parallelogram is opposite sides are parallel, which is what we were doing at the top, and that's how we were able to do all those slope questions. But it's also congruent. So if you find the distance of this one, it's going to be the same distance on the bottom. Basically, if your distance is 12, this one's 12. If this one is 39, that's 39. So whatever number you get for the top, it's going to be the same as the bottom. So we have our answer once we get that distance. Okay, I'm going to slow down on my trick here and see if it makes sense for those who maybe don't see the trick sometimes. Okay, I'm going to concentrate on my x's. My x's are negative 4 and 5. I'm going to count the units between negative 4 and 5. So I'm going to do a number line for my x's. Okay, now you can put the numbers here, like the little tick mark, if you want. I just kind of jump over all that and I go ahead and count. So between 0 and negative 4, there are 4 units. Between 0 and 5, there are 5 units. So my total number of units is 4 plus 5, which is 9. So there's the start of my Pythagorean theorem. Plus, okay, the next one is my y's. So I have a 1 and I have a 3. Okay, I'm going to do another number line, just so we don't get confused with the first one. And this is going to be my y values. Okay, I have 0 here. I have 1, 2, and then 3. I just need the units between 1 and 3. So between 1 and 3, there are 2 units. That's it. So that's going to be my second part of my Pythagorean theorem. And then my answer is going to be C. Okay. These are friendlier numbers, so it should be something that you should be able to do, hopefully without a calculator, but maybe at the end you might need it for the square rooting. We will see. Okay, so 9 squared is 81, plus 2 squared is 4, because this is 9 times 9, so 81, 2 times 2, so that's 4. Okay, add them together, and we get 85 is c squared. Now, don't make the mistake of writing 85 as your answer. Remember, you're not done until you take it and do the square root. So, on this one, since we've been rounding up until this point, I don't want you to lose that practice. We're going to go ahead and round it to 2 decimal places. So, the answer is 9.22 if we round it to 2 places. So, that's your answer. VU is equal to 9.22. Okay, if you leave it the square root of 85, that's fine. So either one would be correct. Okay, so now we're going to move on to the next one. So we have a square. Again, the keyword is square. We're going to put in the values and see what we have. So if Q is located at 7, 0. R is located at 5, -8. Okay. What is the length of SR? So, something that we automatically know about squares, and that's usually the thing that most students know, is all the sides are the same. So if I can find the distance of these two, so remember, when you see the word length, you're going to be doing distance. If I can find the length of these two by doing the distance, then I automatically know what the others are. So that's all we're doing. We're doing the same thing we just did. We're going to find the distance. Now, I'm not going to break this down into number lines, but hopefully you're catching on how to do it. So between 7 and 5, how many units do we have? There should be 2. So that's 2 squared plus. Then my next one is between 0 and -8. And you should realize that that one is just 8 units. And we're going to do our Pythagorean Theorem. 2 squared is 4. 8 squared is 64. We add them together. We get 68. And then remember, we're not done until we actually square root that answer. So C is equal to the square root of 68. I'm going to put that in my calculator and I'm going to round. Now I'm going to round just 2 places. So that's going to be 8.25. There. Okay, so we have our answer now. We're going to move on to 7 and 8, the last two. And again, I want you to have this and ready to go so you have it in front of you whenever you have to do one question, maybe 2 out of this page from the test. You know what to do because we've been kind of writing the steps is what we need to do. Okay, the next one, rectangle is the key word. So we have a rectangle. The rectangle is DEFG below. If D is located at -1, -1, and F is located at 4, -8, what is the length of GE? Okay, so this is actually something very simple to do. If we want to find the length of GE, since it's a diagonal, diagonals are congruent in rectangles. So if I can find this distance, it's the same. So I don't have to do the math twice. I just find the distance of these two, and then that's my answer. Okay, again, we're going to practice by looking at the x's first so we can use this shortcut. So between -1 and 4, there are 5 units because there's 4 units on the positive side and there's 1 unit on the negative. So that's going to be 5 squared plus. Between -1 and -8, there are 7 units because you start at -1 and you count down to -8. So that's going to be 7 units. Okay, and again, if it helps you to make these number lines, then do it so you can use this trick. Now remember, if you can't use the trick, go back to the notes, write down the distance formula, which is that big long square root, and plug them into that formula. Okay, So 5 squared is 25, plus 7 squared is 49. Okay, we add them together. 25 plus 49 is going to give me 74. Now that's c squared. Remember, we have to go through and square root it. C is equal to the square root of 74. We're going to round this to 2 places because 74 is not a perfect square. And we're going to get about 8.60. Now remember, you can leave this as the square root of 74. But that doesn't give us much. 8.60 gives us a distance that we kind of know. Okay, last one that we're going to do, the word is parallelogram. So it's that first basic shape that we learned. If A is at 1, 1, and B is at 8, 5, C is at 5 and negative 5, and then D is at negative 2, negative 9. It's a lot of information there. Okay, it says, what are the coordinates of E? So now, this goes back to something very basic that we learned at the very beginning of the year. Okay, let's scoot this down just a little bit. Okay, if you don't remember how to do this, I'm about to walk you through it, and I'll actually write it down. So this is actually something very simple to do. This was done on our homework 3, I believe it was homework 3. It was done in August before horse show. It's been quite a bit of time before then. So it was months ago. On parallelogram, whenever you have diagonals, they cross at the middle of both of them. So it's going to be the middle of this diagonal and the middle of the other diagonal. So all you have to do is just pick one set of points that are diagonals and find the midpoint, and you'll have your answer. So it doesn't matter which one you pick. If you pick the short one or the long one, you're going to get the same answer. So I'm going to pick this one. It doesn't really matter which one you do. So I'm going to write it down first. So pick a diagonal. Use midpoint formula. Okay, so just so we don't get confused, I'm going to cross out the other numbers that I'm not using so I don't accidentally grab those in my formula. Okay, if you have forgotten the midpoint formula, we usually let M represent the point. We really should be using E because that's the point that we're finding. But I'm just going to write the formula right now. So usually we use M, and then this is the formula. X1 plus X2 divided by 2. Y1 plus Y2 divided by 2. Okay, so now I'm actually going to use the numbers. So I'm going to change that to an E because we're actually finding point E. And remember, I already crossed out the numbers that we are not using so we don't get confused. And I'm just going to pick 2 of the points to plug in for X and then 2 of the points to plug in for Y. It doesn't matter which one you start with. So I'm going to start with negative 2 plus 8 over 2, comma. Now I'm going to do my Y's. So negative 9 plus 5 over 2. Now I'm just going to do my math and then simplify as much as I can. Remember, if you have a calculator, you could just type in this whole fraction, hit enter. That'll give you the first number. Type in this whole fraction, hit enter, and it'll give you the second number. Now I'm going to take it in parts. So this is negative 2 plus 8, which is the same thing as saying 8 minus 2. So that's 6 over 2, comma. Negative 5 plus 5 is the same thing as, well, just 9 minus 5 and then keep the negative. So that's going to be negative 4 over 2. We actually have our answer. We just have to reduce it. So now 6 divided by 2 is 3. Negative 4 divided by 2 is negative 2. There is our answer. If you don't believe me that it doesn't matter which one you pick, you could actually try it with the other 2 numbers, and you should still get 3, negative 2. Okay, so that is it for this page. I want you to keep up with it so you have it. Even though it wasn't a homework assignment, it is something that I could pull from and just ask a question on the homework quiz that we'll be having in December. So make sure that you keep up with the sheet. You've got all the answers on it. So if I wanted to be nice and ask, 2 or 3 questions from here, as long as you paid attention in this video, you have this part filled in. Okay, we're going to move on to the notes now. Okay, so we're going to move on to the parts that say Polygon. Okay, these are our notes. Now, depending on the class, please make sure you write the right date on it and so forth. Since I'm not sure if I will have to use this because I might go into labor earlier than I thought, I'm going to put both of the dates that it could be, just so you know. Okay, so I'm going to move on to the notes now. So, depending on which class you are, either one could work. Our topic is no longer going to be just quadrilaterals, it's going to be polygons. Now, the reason why it's polygons plural is because quadrilaterals are in here, if you see it right there, but it actually has a lot of them. And remember, I mentioned before something about triangles and counting up the sum of them and all of that. This is that lesson where we're actually going to introduce that. And the lessons after the test is when we focus on just triangles. Okay, so this is for polygons. Again, your class could be 2nd, 3rd, 4th, 5th, 7th, or 8th. Okay, so it could be any of them. The date, depending on which class period is seeing this, could either be, so if you're in the odd classes, you would see this on 18th. Or if you are in the even classes, you could see this on Friday. So this would be the 20th. Okay, so a few days in between there. Salud. Okay, so make sure that depending on the class period and when you're watching this, just look at what day it is and you'll write that down. Okay, so let's start writing in some of the notes. It seems like it's a lot, but it's a whole bunch of formulas. Very simple to do. Just plugging in numbers is all it is. And you get to use your notes on this test, so you don't even have to memorize the formula. You just have to know how to use it. Okay, what is a polygon? So a polygon is a shape. Okay, so there are some restrictions to the shape. A polygon is closed, so there are no open parts. Is a closed figure formed by 3 or more line segments. So they have to be straight. That's what line segments are. And these line segments are called sides. So basically, it has to have 3 or more sides. If it doesn't have 3 or more sides, it's not a polygon. Why? Because if it only has 2 segments, like something like this, then it's not closed, so it's not a polygon. Also, there can be no curved parts, and it can't dip in. So just kind of keep that in mind. Okay. What is the sum of the interior angles of these polygons? So let's read through it. Okay, the sum of the measures of the interior angles in any polygon can be determined by the number of triangles that can be drawn within the polygon. Complete the table below and look for a pattern. Find the sum of the degrees in any polygon. Okay, so we're going to go through this very quickly. And we're going to figure out how many triangles we see, how many sides we have, and then hopefully we catch on to a pattern, because basically we're going to write the formula later on into this note sheet. Okay, so let's look at the first one, a triangle. This is what a triangle looks like. It's not the only thing, but that's one example of a triangle. How many sides does a triangle have? Well, it has 3. How many triangles are here? Well, there's only one, right? The picture. So that's one triangle. And I'll go ahead and tell you what the sum is. All triangles always equal 180 degrees. Okay? See if you can figure out the next one. I'll write it in. So it should be pretty simple to do the first part. How many sides does it have? Write it down. Okay, so when I talk about sides, we're talking about on the outside. So the next one, quadrilateral, has 4 sides, right? Okay, how many triangles do we have? So if I break this down into triangles, I have 1, 2 triangles. Okay, how many degrees do we have? Well, if each one is 180, then I have to add them together. So 180 plus 180 is going to give me 360. Okay, we keep going. So again, we count the sides. We're counting on the outside. So 1, 2, 3, 4, 5. This is called a pentagon. Has 5 sides. Number of triangles is 1, 2, 3. Okay, each of them is still 180. And even though, hopefully you can tell, the triangles change in the shape that they have, but they're still triangles. They're different types of triangles. Still triangles, still 180 each one. So now we're going to do 180 plus 180 plus 180. This is going to give me 540. Basically, should be coming up to a pattern to where we can get this answer of this number here without having to repeatedly add. So I hope you remember that repeatedly adding is another way of saying multiplication. So we're going to have to multiply something. So that's what we're trying to figure out. What is the number that we're multiplying by? Okay, I'm going to keep going. Hexagon has 1, 2, 3, 4, 5, 6 sides. Okay. The triangles are 1, 2, 3, 4 triangles. So we're going up by 1 here. So it's not a big deal. Okay, so that means I would do 180 plus 180 plus 180 plus 180. Okay, in other words, instead of writing out 180 4 times, I could just say 4 times 180, right? Okay, 4 times 180 would be easier to do either by paper or in my head or in a calculator instead of having to write 180 4 times. Okay, so 4 times 180 is going to give me the value of 720. Okay, now to be honest, we don't need a picture for the next ones. I mean, you can get a picture in your head, you can write it in if you want, but we have triangle has 3 sides, quadrilateral has 4, pentagon has 5, hexagon has 6, heptagon would have 7, even without the picture, we know that. Octagon, most of you guys know, has 8, because oct, you know. Nonagon has 9. A decagon, has 10. But I think we see the pattern here. You know, it goes up by 1. Hopefully you realize your triangles go up by 1. So if we have 3 sides, we have 1. If we have 4, we have 2. 5 sides has 3. 6 has 4. Okay? So now this one would have 5. This one would have 6 triangles. This one would have 7, and this one would have 8. Pretty simple to do if I have a nice little chart like this. But if I just asked you off the top of your head, what does a dodecagon have? First of all, you might not know what a dodecagon is. You might not know what the next number in the pattern would be. So unless you have a chart, which you don't want to make a chart for like 15 or 18 sides, right? You want to have a formula that you can use. So we're going to try to come up with the formula that we can use here. So let's see if we can find a pattern. On this one, we did the number of triangles times 180. That gave me 180. 2 times 180, 360. 3 times 540, 4 times 180. So this next one should be 5 times 180. 6 times 180. 7 times 180. The last one in this pattern should be 8 times 180. Okay, so this is going to be 900. This is going to be 1080, 1260, and 1440. Now this is just the discovery of it. We're about to write down the formula, and that's what I want you to know for the test, how to use this formula. if I give you either the word or the number of sides, you can use this formula. Okay, let's see if you can come up with something to tell me how I get this number in front of the 180. So 180 doesn't change. So that means in my formula, 180 is going to stay. 180 is like the constant number. You always multiply by 180. What is changing? The number on the front. So this is the one that's going to have a variable, because whenever something changes, variables represent that. So how do I get 4? How do I get 5? Excuse me, 6, 7, and 8? Based off of the number of sides. Basically, I'm asking you, how do you go from this column, number of sides, to this column, number of triangles? So what did you do here? From 3 to 1, you subtracted 2. You subtracted 2 on all of these. So if I'm subtracting 2, all I have to do to get my formula is if I give you the number of sides, subtract 2, and now you know what to multiply by 180. So this is what the formula looks like. N minus 2 times 180. So in the blank it says if n represents the number of sides, that's why I used n instead of x, because it's telling me here to use that, then the sum of the interior angle S can be found using this formula. So they like to use S to represent the sum, so they put S in front of it. So if I said, find the sum of the following numbers, all you have to do is plug in the number they give you, and I don't know if you caught on, but after a dodecagon, they don't give you fancy names, they just give you the number. So 15 gone, n is equal to 15. 21 gone, n is equal to 21, n is equal to 36, n is equal to 48. So we actually can do all of these using this formula here. So in other words, on the test, if it says find the sum of the interior angles of a polygon, like this right here, all you have to do is use this formula. All you need for this formula is to know n. I already told you that n, in this case, is just the number they gave you. Now, if they give you one of these words, they expect you to know what those words mean. So if it says pentagon, you should know that it's 5. If it says triangle, you should know it's 3. Quadrilateral, you should know it's 4. But if they just give you the number gone, then it's just that. Okay, I'm going to take this, put it into my formula, and then I'm going to have my answer. So 15 minus 2 times 180. You can literally put this just into the calculator. And that's it. That's going to be your answer. Now, if you want to go ahead and in your head subtract out 15 minus 2, you know that's 13. Multiply that by 180. You get 2340. Okay, next one over here. You take your 21 minus 2, multiply that by 180. 21 times, not times 2, sorry. 21 minus 2 is giving me 19 times 180, 3420. Okay, next one, 48. Your formula is 48 minus 2 times 180. Now that's another way of saying 46 times 180, so 8280. Okay, now this is the sum of all of the degrees, so technically you could put a degree symbol on all of these answers, not counting off if you don't. Okay, last one in this example, you're going to do 36 minus 2 times 180. Okay, 36 minus 2 is 34, multiply that by 180, and you get 6120. Now these are large numbers. I'm using a calculator for these. Obviously I'm not like putting it down here to show you all of the steps, but I'm just literally just typing them into the calculator. Okay, move on to the next page. Okay, so what about a regular gon? What makes something sorry, not a regular gon, a regular polygon. So what makes it regular? So that's a fancy way of saying, and it tells you here, but I'll write it over here as well. It's a fancy way of saying that all of the angles are the same. Okay, so I'm just going to kind of shorthand here. All angles are the same. Okay, they're the same value. Okay, so I'm going to read out what it says. So the measure of a single interior angle in a regular polygon can be found by dividing the sum of the interior angle measures S by the number of sides. So that's a fancy way of just saying if all of the angles are the same, if I want to find just one of them, I divide it by the number of sides. And that's because there's a triangle, 3 angles are the same. There's a quadrilateral, 4 angles are the same, and so forth. So in order to get each one, we divide by that number of angles or by that number of sides. It's going to match, okay? So what we're going to do now is figure out how many sides this shape has, a regular pentagon. What is n in a regular pentagon? So if you don't remember, go back to the notes that we just flipped over, look at the word pentagon, and look at how many sides it has. Has 5. Hopefully you know that and you don't have to look it up. Okay, so now that I know that it has 5 sides, all I have to do now is take the total number of sums of the angles, basically the formula I just used, and then at the very end divide by 5. That's going to give me each angle. Okay, so what I'm going to do is first the formula. Since it's on the front of the other page and I don't want to keep flipping back over, I'm going to write it down. And now I'm going to replace the value. N is 5, so this is going to be 5 minus 2 times 180. 5 minus 2 is 3. 3 times 180 is 540. So S is equal to 540. Now I could have cheated. We already had that answer. We had it in the chart right here, 540. Okay? So we know that the sum is 540, but the question was not find the sum. That was the 4 questions we did on the front. This one says find each interior angle if you know that this is regular. You can only do this if they say the word regular. Take the number n, which is 5, divide your answer by it, and that's going to give you the angle that you wanted. So 540 divided by 5 is 108. Basically, and I'll just kind of, on this one, I won't do it on all of them, obviously, especially not this 18gon. What this is saying is, we had a pentagon, and that's just a quick sketch of a pentagon, and it was regular. Every single angle was 108. Okay, so all of the angles were 108. And the way we figured that out is first we found the sum, then we divided it by 5 because that's how many sides it has, and that gave us our answer. Okay, now it would be a headache to try to find out an 18gon, like how to draw it, first of all, because it would have to have 18 sides. I can't do that. So I'm not going to draw it, but we can still do the steps we just did. First, n is going to equal 18 because they gave it to you in the word, 18gon. Then we're going to find the sum. We already wrote the formula here, so I'm just going to go ahead and just plug it in. Okay, 18 minus 2 is 16. 16 times 180 is going to give me 288. Sorry, 2880. So let me just read it. S is equal to 2880. Okay, that's not my answer. My last step is to take this 2880 and divide it by the number that is n. So I'm going to divide this by 18. And this is going to equal each one of the angles value. So 2880 divided by 18, 160. So again, I'm not going to go through and draw an 18gon, but just like I filled in this one and they all had 108, if you drew an 18-sided regular figure, they would all be 160. Okay, this is for the inside of the shapes. Hopefully you've caught that. Now we're going to find a formula that lets us use the outside of the shape. And again, you're going to get to use all these notes. So all you have to do is be able to, like it said regular polygon, go to this part of the notes. It said exterior angle, go to this part of the notes. Like it's even in bold. So all you have to do is just go to the notes to get the formula. Okay? Okay, so reading the instructions and what it says. Exterior angles are supplementary to their adjacent interior angle. Find the measure of each exterior angle on the polygon below, then give the sum of all the exterior angle measures. So hopefully we're going to come up with some hallelujah moment, like what's the sum of them every time. Okay, here is the key word, supplementary. Hopefully that's like burned in your brain by now, but if you don't remember, supplementary is a fancy way of saying 180 degrees. So the key word in supplementary is we're going to have to do something with 180. Just keep that in mind. Okay, so I don't know if you caught on, but these are the angles we're looking for. These on the outside. Okay, we have the one beside it. We don't have the one on the outside. But it's actually really simple. To get the one on the outside, you do 180 minus 61. To get on the one outside, you do 180 minus 79. This one, 180 minus 40. Okay, so we're going to do all of those, write in the answer, and see what we get. So 180 minus 61 is 119. This one here, 180 minus 79 is 101. And the last one, 180 minus 40, is 140. Okay, I'm going to circle those numbers since we have a lot written. So 119, 101, and 140. They want us to find the sum, which just means to add, of the exterior angles. So I'm going to go ahead and do that. So 119 plus 140 plus 101. I'm going to use a calculator so I don't have to do it by hand. I add them all up, and this is the number that I get. So this is going to be, this one, carry it, 4, 5, 6, 360. Okay? We're going to move on to the next one and do the exact same thing. So here are the ones we're looking for on the next one. We've got this one, this one, this one, and this one. Now I'm not going to write out all of the steps. We're subtracting from 180, right? Like that's what we're doing. I'm just going to give you the numbers so it doesn't get too messy. Okay, so this one's going to be 109. This one's going to be 56. This one over here is going to be 104. And this last one is 91. Okay, there are my numbers. I literally just am subtracting from 180, so I don't want to have to write, that scrap work step. It's just something you would put in the calculator anyways. Okay, we're going to take all of these numbers we just wrote and we're going to add them together. So 109 plus 56 plus 91 plus 104. Again, I would just use a calculator, add them all up, and you're actually going to get 360. So guess what? You're always going to get 360. Let's do the next one. And we'll see that it's still true. Okay, so these are angles on the outside of the shape. Okay, again, if I subtract from 180, this one's going to be 82. This one's going to be 59. This one will be 93. This one will be 50. And this last one will be 76. So now we're going to add together 82 plus 59 plus 93 plus 50 plus 76. Add them all up, and we get, once again, 360. So basically, what we need to come to is, it doesn't matter what shape we have. If I take the outside values, it's always going to be 360. Now, I know it doesn't make a lot of sense. Why does it always work, even though our shapes are changing? Basically, because in any shape, you could always encompass it in a circle. So any shape that we have, we could draw a perfect circle around it if we can just find the center. So that's why they always equal 360, because a perfect circle is going to be 360. Okay, the last one. Now we already know what the answer is going to be, but I'm going to go ahead and have you practice knowing like where the exterior angle is. So hopefully that doesn't catch you by surprise. Here is the number once we subtract from 180. This one would be 51, 56, 68, 57, 63, and 65. I'm not going to show the math on it. All I have to do now is add all of those numbers up, and I'm going to get 360 again. So the question is, what can you conclude about the sum of the exterior angles measured in a polygon? So I'm going to put on here the sum of all exterior angles in any, so it doesn't matter which one, in any polygon is always 360. Okay, so I'm going to ask the question. I'm telling you right now, I'm going to ask a question where I'm going to say, what is the sum of the exterior angles of, and I can put any shape. I could put triangle, quadrilateral, put a 39gon. The answer will always be 360. So if it is worded this way, sum of exterior angle, your answer will always be 360. So don't have to do any math. It's just automatic. Okay? Because any shape, regardless of the number, don't care what the number is, they're always going to be 360. So I'm telling you right now, I will ask this question. I'll pick a shape. I'll say, what's the sum of the exterior angles of a triangle? You're going to be 360. I'll say, what's the sum of the exterior of this square? You're going to say 360. It doesn't matter what it is. As soon as you see that wording, you know the answer is 360. Okay, we're going to do a few more before we move on to what should be your homework, but I want to go ahead and do a few with you so you know how to do them, and then leave you a few to do on your own. Okay, what is the measure of each exterior angle of a regular hexagon? Now, this didn't say the sum, okay, so don't make that mistake. If it says the sum of the exterior angles, it's going to be 360. This said each exterior angle, and it said the word regular. When it says regular, you're going to do what we did at the very top of the page here on number 5 and number 6. First, you need to figure out what n is. Then you need to figure out the sum. And then you divide the sum by n. So that's literally what we're doing. Okay, first, what is a hexagon? A hexagon is something that has how many sides? If you don't remember, cheat, go to the other page we had on our notes and look up the word hexagon and look at the number we wrote for the number of sides. A hexagon has 6 sides. I find it that students mess up hexagon, pentagon, and heptagon. So those are usually the words that kind of, get interchanged. A pentagon has 5, a hexagon has 6, and a heptagon has 7. So I know it gets a little bit confusing, but since you will get to use your little cheat sheet of the notes, then you don't have to worry too much about knowing those words. Okay, so now we know that n is 6, so our formula is going to be 6 minus 2 times 180. 6 minus 2 is 4, 4 times 180, and again we could cheat, we could look on the other sheet, is 720. So our last step is to take these two numbers, 720, and divide that by 6. That doesn't make sense. I didn't multiply it right. 720 should not be the number. I jumped the gun on the calculator there. Okay, so 6 minus 2 is 4. And where did I put it? Hold on. hexagon is 6. And the number should be 720. Now that's right. So what did I do on this one? What is the measure of each exterior angle of a regular polygon? I didn't pay attention to the question. Okay, so let's backtrack. Sorry about that. Just realized it when I saw that my number was not matching up to what I thought the answer was. Okay, so I jumped the gun on the whole question. It didn't say on the interior, it said on the exterior, and since we know all of them are equal to 360, we just learned that right now, we're actually going to take this n equals 6, we're going to take our 360, and we're going to divide it by 6, and that's it. So I was doing the interior angles, and then that's not what they were supposed to do. This is actually all we're supposed to do. 360 divided by 6 is going to be 60 degrees. And that's it. So if it says the word regular, and it says each exterior, you take 360 every time. I'm going to put the formula here, and you divide it by n. So don't have to do everything that I did. Sidetrack all that. Okay. So now we're going to practice this again and not make that mistake and realize it's actually quite simple. So this next one is worded the same way. It says, what is the measure of each exterior angle? So it doesn't just want 360, it wants each. And then it said the word regular and it said 24 gone. So the key word is, because it says the word regular, all you're going to do is take 360, because it's always 360, and divide it by n. My n in this case is 24, because it's a 24 gone. 360 divided by 24 is going to be 15 degrees. So hopefully that's not too confusing, because I was doing way more than we needed to. Okay? Last two. If the exterior angle of a regular polygon measures 12, so I don't know if you caught on, but basically they're giving you what we boxed in right now. So they're giving you the answer. How many sides does the polygon have? Well, I just told you here's the setup, 360 over n. So I'm going to write that down. And it equals, they actually already told us what it equals. We need to figure out what the answer is. And this is something that I taught my students in Algebra 2, and it's always going to work. This is also something helpful that you can use for ACT. Anytime that you're looking for your variable and it's on the bottom of the fraction, your trick is you can always switch those two spots. This works in trig, which is actually something you're going to learn at the very end of the units after Christmas break. So here's my new setup. 360, and then I swapped n and 12 is equal to n, and then I'm going to get my answer. So now I'm going to do 360 divided by 12, and that gives me the number of sides, which is 30. Okay, we're going to practice it again. So first we have to set up the problem. We know that it's going to be 360 over n, and they're going to give us a value. So let's read. If the exterior angle of a regular polygon measures 40 degrees, so they told us it was 40, how many sides does the polygon have? So here's the key words. If it says how many sides does the polygon have, then, and it's one of those exterior angle questions, this is the setup for it. Okay, the only number that's going to change is that number that you're writing after it. Okay, remember the trick is if you're looking for the variable and it's on the bottom of the fraction. Now you can only do this if it's on the bottom of the fraction. You can switch these. So 360 over 40 is equal to n. You take your 360, you divide it by 40, and you get that n is equal to 9. Okay, so that is it for the notes. We're now going to work out a few of the questions on the classwork side, classwork/homework side, just because I don't want you to go into the test without having that help. Okay, and it seems like my pains have settled down a little bit, so I think I might be able to hold this lesson, but again, I'm just preparing in case it's not. Okay, so this paper here should also be in your packet. It's one that I want you to complete on your own, but we're going to do a few together. We'll kind of jump around and do a few together, just to give you the idea of how to do them and make sure that you're not, setting up yourself to get some bad answers. Okay, first, up at the top, this is going to help you so you don't have to keep flipping back over to your notes. We're going to do a quick summary of the things that we just did in the notes. How do we find the sum of the interior? So if it says sum of the interior angles, you're going to use this formula. S is equal to n minus 2 times 180. Okay, that was the first thing we learned in the notes. What if it says find the sum of the exterior? Now that's a trick question. It's always 360. There is no formula. It's just always 360. Okay? What if they say find the interior angles measure, and then they ask you to find each one because it's a regular polygon? Well, you're going to find S first, so this right here, and then you're going to divide it by the number of sides. That's it. Okay, and remember, n is the number of sides. Okay, so this is true if they say the word regular and they say the word interior angle. Okay, what if they say exterior angle and the word regular? So this is the one where I messed up on the notes. All you have to do is take 360 and divide it by n. So don't break your head over that one and make the mistake I did. All you have to do is divide it by n because all of them will always be 360. Okay? And then lastly, this last two that we did on the bottom, how do you find the number of sides of a regular polygon? Well, first you have to do 360 over n equal to some number that they give you, right? And then the trick I taught you was to switch. Okay? And that's it. So now that you have this quick summary of what we did in the discovery of the notes, so we had to do the notes because it's just the way it works. Now we have this nice little reference sheet that you can use. This is more of what I would use on the test than the other one. Okay, here are some questions that we're going to do. And even though I'm covering this up, you should have this up at the top so you can refer back to it. Okay, so I'm going to pick a side. I'll do the odd numbers. So I'm going to do number 1, number 3, number 5, 7, and 9. Okay, so I'm going to do those with you, let you do the others on your own. I think that'll get a good balance of some that you have to do on your own. Okay, what is the sum of the measure of the interior angles of a pentagon? So I see the word sum, I see interior, and then I see the word pentagon. Okay, so I go back up to the top, I get the right formula. So S is equal to, N is equal to, pentagon is 5. So I get 5 minus 2 times 180. We could cheat and look on the notes, but hopefully you realize it's just 3 times 180, and you get 540. Okay, you will do the next one on your own. The only thing that changes is the number we plugged in for n was 5. On this one it'll be a 27, and obviously it'll be a larger number. Okay, we'll do 3 together. What is the measure of each interior angle of a regular octagon? So it says each, it says interior, and it says regular. I go up to the top, I find where it says interior angle, I find where it says regular, and I get this formula, S over N. So I'm actually going to do what I just did. I'm going to use this formula here, but then I'm going to go back and I'm going to divide it by the number of sides. Now the word is octagon. Octagon means it has 8 sides. So first thing we're going to do is find S. 8 minus 2 times 180. 8 minus 2 is 6. 6 times 180 is going to be 1080. Okay? So now that I have that this is 1080, my next step is to take the 1080 and divide it by 8, because n was 8. And then there's my final answer. 1080 divided by 8 is 135. Okay? You will try the one beside it. It's worded exactly the same, but this time it changes to the word 20gon. So the only thing that's going to change is instead of having an 8, you're going to have a 20, and obviously the number will change because it'll be a larger number. Okay, we're going to do number 5. Okay, 5 angles of a hexagon measure 119, 129, 104, 139, and 95. What is the measure of the 6th angle? A hexagon has 6 sides. And all we have to do is, if we know the sum of a hexagon, we subtract those numbers they give us, and that gives us our answer. That's it. So first we have to figure out, do we know what the sum of a hexagon is? Technically, we already have it in the notes, but we're going to go ahead and work it out because usually you're not going to be given that number. So first we're going to find the sum of a hexagon. Hexagon is equal to 6, so we're going to find that number. 6 minus 2 times 180. Now again, you can just type that into the calculator. That's going to be 4 times 180. That's going to be 720. Okay, there's my sum. I have all of the angles except for one, so all I'm going to do now is 720 minus 119 minus 129 minus 104, and then I keep going, minus 139 minus 95. Okay, you could just add them all together and then subtract. I'm just going to put them all into the calculator and subtract. Once I subtract them all out, my answer is 134 degrees. That's the angle that was missing. That's it. Okay, now, number 6 is different. It's not worded the same way. This one says sum, so I'm not going to do this one. It says interior angle is 1620. So they're telling you the sum of this polygon is 1620. It says how many sides does this polygon have? So I'm going to set this one up for you, but you are going to solve it on your own. Here's the formula. They gave you the sum. So they already told you that the sum is 1620. They want to know how many sides. So n is my unknown. And then this is 180. Basically, you're going to solve for n. You're going to distribute the 180 in. So hope you remember how to distribute. You're going to write that out, and then you're going to combine like terms until you get n by itself. So you're not done until you find n. Okay, so see if you could do that one on your own. I've set it up for you. Okay, we have 2 more that I'm going to do with you here. The sum of the interior angles is 3960. How many sides does the polygon have? So just like I set this one up, this one's going to be the same. So we're going to go through the same steps. S is equal to n minus 2 times 180. They told me that the sum is 3960. I don't know what n is. That's what I'm trying to figure out. But I know that the formula looks like that. I'm now going to go through and distribute my 180. 3960 is equal to 180n minus 360. Okay, so I distributed in the 180. Then I'm going to do the opposite of negative 360, which is to add 360. Okay, I'm going to keep going with my work over here. Okay, so now I take my 3960, add 360, I get 4320. My last step is to get n by itself, so I'm going to take this and I'm going to divide it by 180. My answer is 24. So 24 sides. Now, is this the only way to work it out? No. Some of you might have chosen to divide the 180 first instead of distributing to make the numbers a little bit friendlier to work with, and that would have worked as well. Okay? I just like to distribute, so. Okay, last one that I'm going to work out on the front with you. This one says, what is the sum of the measure of the exterior angles of a nonagon? So this is one of those trick questions. It says, what is the sum of the measure of the exterior angles? So keep that in mind. Go back to your notes or go to the top of this page to figure out what you would do there. Now this one does not say the sum. This one says, what is the measure of each exterior angle of a 20gon? And it says the word regular. Okay, 20gon just means that n will be 20, so that's pretty simple. But when it says each exterior and it says regular, we have to do this. We're going to take 360 divided by n and set it equal to our number. Oops, not divided by n, divided by 20. Because they told us what the number is, and that's going to give us our answer. That's it. So it's the measure of each exterior angle. Take 360 divided by 20, and that's going to give you your answer of 18. That's it. Each one is equal to 18. Okay? You'll try number 8 on your own. And then going to the back again, I'm going to do the odd ones. I think the odd ones are good ones to do. It gets more of them done because there's 17 total. Okay, so I'm going to do number 11, number 13, 15, and 17. Okay, if the interior angle of a regular polygon measures 108, how many sides does the polygon have? Okay, so I'm going to look at the keywords. It says interior, it says regular, it gave me 108, and it says how many sides. When it says how many sides, we're going to be looking for n. So keep that in mind. Okay, it also said interior, and it says that they're 108. So the first thing we have to do is figure out what the exterior is. And the reason why we need the exterior is because that's going to give us what we need to set it equal to. So the interior angle of a regular polygon is 108. To find the exterior, you would do this. 180 minus 108. Okay? 180 minus 108 is 72. Okay, that's not going to give us our answer, but that allows us to set up now this part of the problem. You know that always on the outside, all of them always equal 360. If I know the number of sides, if I divide that by n, which I don't know the number of sides right now, so it's going to stay n, I set that equal to 72, because that's what we found to be the exterior angle. I couldn't have two unknowns, so I had to either know the number of sides, which I didn't, because that was the question, or I had to know the exterior angle, which I did, because all I had to do was subtract it from 180. So now that I have that 72, I can do the trick, which is take these two and switch them. So 360 divided by 72 is going to be 5. So n is equal to 5. And that's it. Now this one, the way it was worded, it was a little bit tricky. They wanted you to first subtract from 180. Then after you did that, you could switch these two. All you're doing is 360 minus 72. Okay? The next one is actually similar to one that we did on the front. It's basically the same way we did number 5. But without all the word problem. Instead of giving us like this big long word problem, they gave us a picture. They said solve for x. Here's x. It's my unknown. You might be thinking, well, you have 2 unknowns. You've only been given 1, 2, 3, 4, 5 angles, and there should be 7. But remember, this box actually has a number, and that's 90. So what you have to do first is find the sum of this shape's angles, and then subtract all the ones they gave you, and that'll give you x. So this is basically how we did number 5. So first, here's my formula, but I need n. How do I get n? There's 2 ways to do it. Either count the number of corners, which are your angles, or count the number of sides. So I'm going to count the number of sides. So 1, 2, 3, 4, 5, 6, 7. There are 7 sides. Also, there's 7 numbers. X is a number as well. So it's going to be 7 minus 2. 7 minus 2 is going to give me 5. And then 5 times 180 gives me 900. So S is equal to 900. Now all we have to do is subtract all of those numbers, and we have our answer. So again, you could add them up. I'm not going to do all that. I'm just going to subtract in parts. I'll be putting these all into the calculator. So I do all those. Then I keep subtracting. So I did 140. I'm just going to cross them out as I go. 136, 142. Then I'm going to do 150. Don't forget the 90. And then finally 148. Once I subtract all of them out, so I do 900 minus all of those, I get an answer, and that answer is 94. Okay, that's what X is. It's the leftover piece. Okay, so we're going to move on to the next one. Now, number 14 is going to require you it's going to be a little bit more of a challenge. So if you pay attention to how we do 15, it won't be so bad. Because 15 actually wants you to plug it back in, and 14 they don't. Okay. Okay, so now we're going to move on to 15. We have to find the measure of angle B. So after we get X, we're going to plug it back into this one here. So don't forget that. Okay. So now, if I have to find the measure of angle B, I'm basically doing what I just did at the top. I'm going to find all of them and set them equal to the sum. So if you already know the sum, you can kind of cheat and look at the chart. This has 4 sides, so we should know that the sum is 360. But let's say you don't know it and you don't have the notes. You would just use the formula to find the sum. So the sum's formula is n minus 2 times 180. So we've been using that the whole time. Okay, since this has 4 sides, you would do 4 minus 2 times 180. 4 minus 2 is 2. 2 times 180 is 360. Okay, now this was just so I had a whole, because now what I'm going to do is I'm going to take everything on the inside, all 4 parts, and set them equal to my whole. My whole is 360. Okay, so now I'm going to take 8x plus 7 plus 5x plus 18 plus 14x minus 11 plus 10x plus 13. Set it equal to 360. Now it looks complicated, but everything is on the left-hand side is just going to get added together or subtracted together, and you'll get your answer. So let's go ahead and take this in parts. We have 8 and 5, that's 13. Plus 14 is 27, plus 10 is 37. So that's 37x. Okay, now we're going to add in the numbers. So I'm going to try to group up the ones that are going to be easier. So 7 and 13 is going to give me 20. 20 plus 18 is going to give me 38. And then subtract 11. So it's going to give me 27. Equals 360. Now it's not such a big problem. Pretty easier to do. So now I'm going to subtract 27 on both sides. 37x is equal to, so 360 minus 27 is going to give me 333. Divide that by 37. Don't know, but this should give us a whole number. And it gives us 9. So x is equal to 9. Now remember, this one didn't say find x. This one said find angle B. So now I have to go back in and I have to find angle B. But it's pretty simple because now that I have x, all I have to do is 8 times 9 plus 7. Now, I could put this in the calculator, but you should be able to do this one, hopefully, in your head. 8 times 9 is 72, plus 7 is 79. No. Yes, baby, that's blue. Okay, that's our final answer. I ran into the 79, so let me fix that. Okay, we're doing one more together, and then again, I'm going to give you the rest of them to do on your own so you can get that practice in, but you can always ask me for help if you need to. Okay, so the last one says find the value of x, and I'll start you off on 16 in a second. Just to kind of review the one that we didn't do that was a little bit different, you are going to take and find the sum of however many sides this has. So this has 1, 2, 3, 4, 5, 6 sides. So find the sides, that's 6. So n is equal to 6. Find the sum, so I'm going to let you use the formula for that. All you have to do is put in 6 in place for n. When you get that number, just like I set this equal to 360, you're going to set equal to the number that you get there. Okay? Once you do that, you take every single part, just like we did here, set them equal to that number, and solve for x. The only difference is you don't plug this one back in. So it's actually a little bit easier. Now 16 looks difficult, but it's actually not that bad. So I'll kind of walk you through it, but let you figure it out. All they want is the value of x, so there's nothing to plug in. It says in the figure below, it's a regular polygon. So the key word is regular. Regular means all of the angles are the same. So I'm going to try to show you a shortcut for this one because it's going to be super long if you don't. First, we're going to count how many angles it has, or how many sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 sides, so there are 10 angles. So there's 10 of these things right here. All I need you to do is same thing we just did at the front. N is equal to 10, not at the front, sorry, on the top of this. Find S using N is equal to 10. Then you're going to do this 10 times. 10x plus 4, 10 times, blah, 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 blah. You're going to write them down. Instead of making you write it down 10 times, I'm going to try to help you by doing a shortcut. Remember, addition, repeated addition is just multiplication. So if you write it this way instead, and remember this number is the sum that you get, then you can get the answer and not have to do all of this. Okay? Now you couldn't do that on these because they're all different. Since they're all different, we have to write them all out. You can do that on 16 because they're all the same. And that's why they only gave you one of them, because they're all the same. Now, if this confuses you, write out 10x plus 4, 10 times, and then set it equal to your sum. But it's going to be really long. So I would suggest doing this instead. I think that'll help you out. Okay, we're going to do the last one now. This is all they give us, and then they said find the value of x. So they don't want us to plug this one in, they just want us to get x. This is actually quite a simple question because all of these are exterior angles. Every single one of these. How do I know they're exterior angles? I know they're angles because they have a degree symbol, and I know they're exterior because they're on the line with the arrows, so they're exterior. If you remember, every single exterior angle will always measure 360. So all I have to do is set it equal to 360, and I'll have my answer. Because every single one of them is always equal to 360 after you add them. So that's what I'm going to do, and then get my answer. Okay, so I have to grab all of these. I can't do something like this because they're not the same. Okay, so 5x plus 4 plus 4x plus 9. And I suggest just start with 1, and then I go clockwise and go grab all of them so I don't accidentally skip one. Plus 9x minus 6 plus 4x plus 1 plus 7x plus 4. And they always equal 360 because every time you have exterior angles are always going to equal 360. Okay, I'm going to start combining my like terms. I always start with my x's first. So again, it's going to look complicated at first, but then it's going to clear up. So I have 5 plus 4. That's 9. I keep going. Plus 9 is 18. Plus 4 is 22. Plus 7 is 29. So there's my x's. Okay, now I'm going to take my numbers. I have a 4 plus 9. So 4 plus 9 is 13. Minus 6 is going to be 7. Plus 1 is 8. Plus 4 is 12. All of this equals 360. Okay, I keep going, and now I'm going to combine my like terms. So I move the 12 to the other side. 29x is equal to, so 360 minus 12 is going to be 348. Divided by 29. And we should get a whole number answer, which is 12. Okay, so not too bad. I've kind of helped you set up on the ones that we didn't do. Again, if you need to pause it at any point to copy anything down, go ahead and do that. 10 and 12 at the top were the only ones that I didn't talk about, so let's make sure we talk about those. Okay, if the exterior angle of a regular polygon measures 9 degrees, how many sides does the polygon have? So there is a way to set this one up. We did 2 examples of this. It was the last 2 in our notes. So I'm just going to put that over here just so I don't have to like give you more hints. Go back to your notes. Last 2 on notes. We did exactly the same way. Okay? Number 11, which I actually did, was the one that was a little bit more difficult because we had to do that side work, which I've already done for you. Okay, this next one, find the value of x. It's the same thing that we've been doing down here, but without a whole bunch of expressions. So first, find the number of sides of this shape. 1, 2, 3, 4. Find the sum using this formula right here. And then add all up. So you're going to add 79 plus 55 plus x plus 110 and set equal to whatever s is. So whatever you get for s. And that's how you're going to solve for x. Okay? So I think you could get all of these done. And then you could use this paper here as kind of your cheat sheet for the test. You can use anything for the test. You know, I'm not going to say like no notes, everything. But my suggestions would be to use so I'm going to put this under the screen in just a second. Use that Quadrilaterals page that we started with that has all these marks on it. Because it gives you a quick rundown of what all those 4 shapes that we learned in the lessons are. And then I would use this one instead of the notes. I think this does a better job of kind of having everything there, but you're welcome to use the notes as well. And then finally, this one, the one we did at the very beginning of this video. I think all 3 of those would be great ones to use and have out during your test. I think those are the ones that are going to help you the most. Your only assignment is to finish this paper here that we were working on, interior angles, the more practice. So finishing the questions that we didn't get done, that's your only homework. And then study for the test. There isn't a study guide. I am going to make it multiple choice. It's going to be on forms. You'll try your best on it. I'll pull out questions that were hard on the homeworks and things like that, and I'm not going to include those. So there's a few where I kind of put stars on them in the notes and stuff like that. I'm going to keep it to very simple, basic questions. So if you've kind of listened, it's not going to be too bad. You will have at least one question from each of the shapes. So you'll have at least one parallelogram, one rectangle, rhombus, and square. You'll have a question from these here. And you'll have a question from this one here. Okay? So at least one of each. A few of them you'll have obviously like a couple more to get all of them in. Okay? So what we're going to do now is stop the video here, study. Your test is Monday for odd classes, Tuesday for even classes. Okay?
Where'd you go?